Hello, good day everyone. This is Professor Roger Flores of the Department of Electrical Engineering, the professor of this subject EE30, Electrical Engineering Utilities. Today we are going to discuss Chapter 1, and this is entitled Electricity Theory. No? So here we are going to discuss the brief history of the electricity and how electricity is produced and other theories that involve the production of electricity. So to start with, let's proceed to 1.5 entitled the relationship between the magnetism and electrical current. Okay. So, what is magnetism? Okay, of course, magnetism is a force of attraction between ferromagnetic metals such as iron, nickel, and cobalt, and a force of repulsion between diamagnetic materials such as antimony and bismuth. Okay, so if it is opposite poles, north and south, they are attracting. So, okay, so we have this one. So there is an attraction between opposite poles. Okay, so one of the person contributes much in the study of electromagnetism is this William Gilbert, and he is known as the father of magnetism. William Gilbert is the father of magnetism. So how do magnets work? So of course we have this unlike poles, there is an attraction, but if we have this like poles, then we have this repulsion. There are two. Okay, so we have that illustration. There are two poles in a magnet, north and south poles. When poles meet, contrary poles will attract each other, while like poles repel each other. Okay, we have these types of magnetism. Perimagnetism, type of permanent magnets that occurs in a solid in which the magnetic fields associated with individual atoms. Okay, so perimagnetism. Then we have also this ferromagnetism. This is a physical phenomenon in which certain electrically uncharged materials strongly attract others. Anti-ferromagnetism. So, and this are anti-ferromagnetic materials. The magnetic moments of neighboring electrons point in opposite direction. Walang attraction na mangyayari. Sana ba tayo? Okay. So, these are the three types of magnetism: ferrimagnetism, ferromagnetism, and anti-ferromagnetism. Another one is paramagnetism, kind of magnetism characteristic of materials weakly. Parang mayroon tayong weak, no? Na weak yung attraction or repulsion. Okay. So, weakly attracted by strong magnet named and extensively investigated by British scientist Michael Faraday in 1855. We have also this diamagnetism, kind of magnetism characteristic of materials that line up at right angles to a non-uniform magnetic field and that partly expel from their interior magnetic field in the other place. Okay, so mayroon tayong tinatawag dito na bumabalik dito si Benjamin Franklin, no? So, it is the flow of current through a conductor. Current must be forced in a flow in a conductor with the presence of a charge. Dito po na mag-start na yung tinatawag natin na generation using generator. Mayroon na tayong tinatawag na electromagnetism dito. So, discovered electricity by Benjamin Franklin, and this is through his experiment in lightning, and also Alessandro Volta. Alessandro Volta, as we can remember, he was the first one to develop battery. So what is the relationship between electricity and magnetism? So the force of magnetic field can produce an electric current in a conductor, flow of electrons or electric current. Okay? So on the other hand, produces magnetic field. Okay, so we have this one. Then we have Michael Faraday, an English physicist chemist whose experiments contributed greatly to understanding of electromagnetism. Some of Faraday's contributions to science: electric motor, discovery of Bunsen, electromagnetic induction, electromagnetic generator, electrolysis, and electromagnetism. So, ano po ba yung tinatawag natin na electromagnetism? It is the interaction between magnetism and electricity. It is produced when electrical current flows through a simple conductor, and as a current passes through the conductor, magnetic field is formed along the whole conductor. So, yun po yung tinatawag natin na electromagnetism. Mayroon tayong conductor dito, mayroon tayong kuryente na dadaan dito sa conductor natin, mayroon tayong magnetic field mapoproduce along the way, no, dito po sa surface along perpendicular to the conductor na mayroong kuryente na dadaan. Okay, so electromagnetic induction, it is the process of generating electricity with a magnetic field. The voltage is produced in the conductor. Okay, so when there is a reversal of the direction of the current, then there is what we call as the generation of voltage in the surface. Okay, so voltage is produced in the conductor when the conductor is moved through a magnetic field. Pag mayroon tayong magnetic field dito, mayroon tayong conductor na i-move natin up and down to cut the magnetic line of forces, mayroon tayong mapoproduce na electricity dito sa conductor na nag-cut ng magnetic field. Okay, so minsan yung magnetic field natin ay tinatawag natin na flux. Okay, so pag mayroong mga fluxes dito, okay, this is your pole phase. Mayroong mga fluxes dyan. Okay, mayroong mga fluxes dito. Pag puputulin natin gamit itong conductor, okay, if we are going to move this conductor down, up, then there is a cutting of these fluxes or magnetic line of force. There is what we call as induction or electricity produced in this conductor that cuts the magnetic line of force. Okay, so yan po ang tinatawag natin electromagnetic. When a magnetic field is moved across a fixed conductor, the voltage goes through to flow through the conductor. Okay, so dalawang purpose natin, dalawang gagawin natin. Either the conductor will be moved up and down, or steady state or stationary itong conductor natin, yung pole ang ating i-move natin up and down. Okay, so pwede rin basta kay mayroon tayong tinatawag na relative motion between the magnetic field and the conductor that cuts the flux. So mayroon tayong tinatawag na relative motion. So yan ang tinatawag natin na induction. Okay, so para this law magnetic induction, we have this formula here. So the closed integral of the magnetic field, okay, so times yung length ng conductor that will cut the flux is equal to the negative of the, ayan dito, yung sa magnetic field density, no, per unit area, divide by the rate the time, no. So that is your magnetic induction. So magnetic okay, ampere, Andre Ampere suggested it is formed whenever an electrical energy, okay, so ano bang nangyari ito? Okay, dito na. Electrical energy is in motion when the conductor no longer move through a magnetic field, current flow stops. So ayun, pag mag-stop na yung movement natin, either of these two, yung conductor yung nag-move or yung field, magnetic field ang mag-move, o kahit saan sa kanila, if one or if they will stop moving, then there is now no longer we are now not anymore producing electricity or current. The current also will stop. Okay, so when a constant voltage is applied closed circuit, the voltage forces currents to move in one direction through the conductor. Okay, pag mayroon tayong voltahe na i-apply doon sa circuit, mayroon tayong pressure applied to the electrons to move, and that movement then it will result to electron flow. That electron flow, the rate of flow of that electron is current. So current flows in one direction, the magnetic field of the electrons aligned and combined to produce strong magnetic field that exceeds or extends around the conductor increasing voltage thus the increasing current flow. Pag malaki yung current flow, malaki din yung voltage generated. Okay, so it is they are, as I've said a while ago, they are directly proportional. Okay, so decreasing the voltage thus decreasing also the current flow. Okay, because the magnetic field also reduced. So we have this Ampere's law. The magnetic field in space around an electric current is directly proportional to the electric current serves as its source. Okay, so Ampere's law states that for any closed loop path, the sum of the length elements times the magnetic field in the direction of the length element is equal to the permeability times the electric current enclosed in the loop. So we have this loop here. Okay, so we have this the delta L, the distance, the length, and the delta B, the density of our magnetic field, and we have this current I here. So we have this formula. Okay, so accelerating charge, no, and ang accelerating charge particles produce an electromagnetic wave. Electromagnetic waves are electric and magnetic fields traveling through an empty space with the speed of light, that is more or less 186,000, or it is 186,000 miles, no, per second, or yeah, that's it, no. A charged particle oscillating about the equilibrium position is an accelerating charged particle, in which these electromagnetic waves transport energy through space. The energy can be delivered to charged particles in large distance away from the source. Okay, class, I think that ends our discussion here. This chapter 1, and I hope that you learned many things with this chapter 1, the introductory portion of electricity, our subject, the theory of electricity here. So thank you very much, and if you think that you learned many things, then try to subscribe my YouTube channel, so that if I have new video that will upload or uploaded, then you will be notified. Subscribe, click the notification bell, so that you will be notified whenever I have new video that will be uploaded. Okay, thank you very much. God bless. Good day to everyone.